In this video, I'd like to focus on a conceptual understanding of the photoelectric effect. The photoelectric effect is a phenomena that occurs when light shines on a piece of metal and electrons are emitted. Now sometimes electrons are not emitted, and other times if they are emitted with a slow velocity or a faster velocity. So it was Einstein who came up with a relationship that would allow us to predict if electrons are going to be emitted and to be able to determine how fast they would be released. So as you can see down here, we have a piece of metal. They called it a metal slab. And the electrons are buried in the molecular structure of that metal slab. So it would take work in joules to be able to release an electron from that metal. Let's just pretend for easy numbers that it would take 10 joules of work to release an electron. Well, we are going to try to release the electrons with 4 different kinds of light. We have infrared light, red light, blue light, and ultraviolet light. If we look at the electromagnetic spectrum, you can see that each of these 4 different kinds of lights have different amounts of energy. And so in order here, infrared light has the least amount of energy, and you can see ultraviolet light has the most energy. And blue light would have more energy than red. So for the sake of our story, let's pretend that infrared light is going to bring us an incoming energy of 8 joules. Well, I shine infrared light on the metal, I send down my 8 joules, and that's not going to be enough to release the electron. So basically the photoelectric effect is not going to happen when I use infrared light. But now let's move up to light that has more energy. Let's use red light. Red light, let's pretend, gives us an incoming energy of 10 joules. And shine my red light, and it takes 10 joules to release an electron, so I would expect an electron to be released. But there's no extra joules, so therefore that electron is just going to sit there because he doesn't have any energy to turn into velocity to move. Now I'll do it again with blue light, which has even more energy. Let's say 12 joules. So I shine 12 joules. It takes 10 to dig out the electron. And so this electron now carries with it 2 joules. And I can use kinetic energy as 1/2 mv squared to calculate the velocity of this electron, and that 2 joules would give it, I'll say, a slow velocity. But then when I use ultraviolet light that has even more energy, let's say 20 joules, so I have 20 joules of incoming light. It takes 10 to release the electron, but now this electron takes with it the 10 extra joules, which would turn into be a larger velocity. So Einstein came up with this relationship. Yes, I guess it's an equation, but it's really just a conservation of energy because HF is the incoming energy. So that HF would be the 8, the 10, the 12, or the 20. And then you have to take the incoming energy in joules and subtract off the work function in joules, and this would tell you if you have any extra kinetic energy to give to the electron. And then we can use that kinetic energy to calculate the velocity at which the electron would fly away. So here is the same story that I just described to you in words if you'd like to read it a little bit more slowly to yourself. But I hope that helped give you a better conceptual understanding of the photoelectric effect.